Welcome back, guys. This is my small block square body. I know it looks like a total mess right now, but this is actually a pretty simple harness compared to modern day vehicles. I always tell people, the only problem with vehicles that they buy are the previous owner. And obviously, the previous owner is to blame to this, or at least the shop that did the engine swap for them. Is this gonna suck? Honestly, probably. But it's gotta be done, man. I gotta hear this engine start.
So then, let's get to work. We've really got to trim back some of this harness. It is an absolute disaster from the previous owner or mechanic that touched this thing. An engine that requires less than 5 wires to run should not be this busy in the engine bay as far as the wiring harness goes. So our goal is to remove as much of this unnecessary wiring as we can. A couple of these leads are used to power the interior fuse box and also bridge the gap between the junction on the firewall that I was showing you earlier. So we start by cutting those wires to length and hooking those things up properly. And then basically we're just gonna go through and cut out any of the stuff that we don't need, and the stuff that we do need, we're just gonna label it with a piece of masking tape and a marker. Luckily I did take some photos of the wiring before we started cutting this up, just to kind of figure out what wire does what. Because this was a swap truck, the original wiring diagrams for it are going to be mismatched because they've obviously done a lot of work to get this engine running when they did the swap in the first place. I would have spent a lot more time figuring out which wire went where if I hadn't done so.
We pretty much pulled out a good chunk of the harness that just didn't need to be there right now. A lot of it's just main battery wiring that we simplified in the last video. If you didn't see that video, you can click right here, it'll take you there, and check out all this epic wiring that we did last video. Now that we've eliminated a lot of this just disaster of a harness here, the only thing that I want to figure out now before we start buttoning everything up is how I want to do the power distribution for the S terminal on the starter. Luckily, past Tyler was thinking of present Tyler when I put this thing together, because getting at the S terminal on this thing would have been even harder than getting at the B terminal, which you know was kind of a pain in the butt when running the starter wire. But I was thinking ahead, and I made a little sub harness off of the S terminal to a plug that's a lot more accessible than the S terminal itself, and you can kind of just see it down there, right there. So that's just basically a connector, and then the plan is to run from that connector, make a sub harness that runs from there up along the firewall, and then has a second connection up here where the engine harness is also going to plug in. So let's go ahead and make that sub harness.
First order of business is routing our starter wire the way that we want to route it, just to get a general idea on length. And once we're happy with the routing, we can go ahead and cut this wire to our desired wire length. Say that 10 times fast. Now it's time to install our 1-pin connector on the one end of our wire. This is going to be the side that connects to that little sub terminal that I made on the starter S terminal. I'm just using an Amazon kit for connectors. I know a lot of you really like the Deutsch connectors. I just don't like the look of the Deutsch connectors, and most of the time, unless you're going to spend a bunch of money, they come in that ugly gray and orange color scheme. So we're just going to go with the simple black GM style Amazon special connector kit, which at the end of the day is going to work perfect for this application. After we install the end, you can see we're going to bend this 180 degrees, and that's just to start forming this wire. Especially when we shrink tube it, we're going to want to have that 180 degrees in there beforehand, and that way it's going to route a lot easier once we install it on the starter. And speaking of shrink tube, here it is again, struggling to push the shrink tube all the way over. Once I got it all the way onto the wire, I actually decided that I was going to heat shrink the connector side. I made the mistake of heating this thing at both ends. What I should have done is started at one end and went down to the other. Obviously that left this in the heat shrinking, and that is no good. We want this to be a completely sealed unit and keep moisture out. And here is the solution for that. Just a couple of repair heat shrinks. It's unfortunate that this isn't 100% uniform, but these are going to be sitting in places where you can't see them anyways, and it still looks half decent regardless. And there you have it, the engine side of the starter sub harness. Back on the truck this harness goes, and now we can move on to the body side of the starter wiring.
Alright, ignore the little rough draft that I made over here, but this is pretty much the entire engine bay harness as it sits. I know it looks pretty confusing right now, but let me try and break this down for you. Here is our 6-pin engine harness, and that feeds all of the things on this side of it. So coolant temp sensor, oil pressure switch. So that's for the gauge, and then that's for the light. And then obviously that's also for the coolant gauge. We got our distributor down here. So there's 2 wires off the distributor. There's the positive, and then there's the tach wire for the tachometer. And then we also have the choke, positive and negative, the electric choke. And then the last sub harness that we made was the 1-pin harness. That's what we're gonna focus on first, is getting all of this stuff right here kind of figured out. Starting with the relay.
This is an automotive relay. Think of a relay like a remote control switch. Instead of you flipping the switch with your finger, electricity flips it for you. Inside the relay there are 2 sides, a control side and a power or load side. The control side consists of terminal 85 and 86. In our case, terminal 85 is going to be our power side of the control, and terminal 86 is going to be our constant ground. Terminal 30 is going to be our main power input, and terminal 87 you can consider as the main power output. This goes to whatever load you're trying to turn on with our relay. When power goes into 85 and out of 86, the relay clicks shut, allowing power to go through our load side of the relay. The reasons we use automotive relays is to let a low current circuit control a higher current circuit, as we don't want a bunch of higher current traveling through a circuit that goes inside of the cab.
So now that you know how a relay works, we can kind of go over how we're going to feed the starter power using the ignition switch. So the ignition switch obviously needs an in feed, which is going to be from this ignition feed right here, and an out feed, and that's what feeds the relay. It's going to energize pin 85, creating that magnetic field and locking that relay closed, which is then going to send that power down to the S terminal at the starter. And we're going to do this by using something like this. So this is just a relay holder. Basically, you just cut and splice it into your harness, and then it sits up on the firewall all nice. We'll riv nut it with a screw. Sits up on the firewall all nice and easy access if we ever have to diagnose or do anything with it. So let's mount this relay and start splicing it into the harness as the diagram states. So I think the plan is to mount this relay holder somewhere in this general area, and then that way we can run kind of the power feeds and stuff together with those that got to be connected to this terminal anyways for the interior fuse box. So I'm thinking like maybe here or something, or close to there. I think that'll probably work good.
Pro tip, if your drill does not fit in an area and won't drill a hole straight, abort mission.
Bruh. We're just gonna ignore the rough draft here. As you saw, my drill kind of didn't fit in this area, and I still decided to go ahead with it like an idiot. I thought it would work, and the hole just ended up being all wonky. So that's going to be my solution for that. Luckily, this stuff is all going to kind of hide that, because now I just got a random push clip in my firewall, but it's better than leaving that hole open. We're going to seal that up too, and when we're done, we'll permanently install that clip. And then hopefully that is good to go as far as rust and stuff goes. So let's seal up this second hole, this proper hole that I drilled, and that's actually going to be our mounting point for the relay box.
At this point, you guys know the drill. We're going to go ahead and seal up this hole with just some general rust proofing. I'm using rocker guard for this. This just prevents rust on the bare metal. Then we can go ahead and install our nutsert, followed by mounting the relay holder. And now that we have everything in place, we can start doing our actual power distribution wiring.
So some of you eagle-eye viewers may have realized that the way that I have this drawn out and set up, and the way that I've wired it right now actually, this relay isn't actually doing what it's supposed to do, and that's by taking the low current control side and the high current load side and separating them through the engine bay. And that's because I have these two wires teed together. So no matter what, the high amperage stuff, even the load side of the relay, is going through that ignition feed wiring. So what we're actually going to do is we're going to go from this to this. Instead of teeing this off together and pulling all of our current through our ignition switch, we're going to give the load side a direct power feed from that firewall junction. Now, I originally did want to have a separate fuse for the load side of the starter, and it is a good idea to do that. However, that firewall junction still does have the mega fuse on the battery. If this were to pull a crazy amount of amperage, it would pop that fuse. It would probably melt this starter relay before it did that, but at the very least, we are still protected by hooking it up to that firewall junction. Luckily, this is a pretty easy fix. It is going to get a little bit busy on this junction. As you can see, there's quite a few things hooked up to it already, but let's fix this. So here we go. Way better. All right, so with that starter relay fully wired in, theoretically, this thing should crank right now. However, before we go ahead and crank this thing over, I want to put some manual transmission fluid in the transmission, because when we're cranking this thing over with that dry, the whole transmission assembly is still going to be spinning because I don't have the clutch hooked up. Now, I'm hoping I'm not going to end up having to put the drive shaft in the back of this thing, because my drive shaft actually needs a front U-joint, and I'd like to do that before I put the drive shaft back in this thing, but I don't know, we might just go ahead and fill this thing up just enough to make sure that the gears have lubrication. So according to the internet, this thing only takes 1.5 quarts. I think we're gonna put 1 liter in it and call her good. If I can get 1 liter into this thing, man, holy crap, this fluid is thick. I'm used to pumping automatic transmission fluid with this thing, so the 80-90 is a workout. All right, this is my official future reminder to top up the manual transmission fluid in this thing, since I only put 1 quart in, just so that we can crank this sucker up.
Unlike more expensive roller cam, the flat tappet camshaft I've installed in this engine while it was out requires a very specific break-in process. And this all starts with a good quality break-in oil. I'm using Lucas Oil products, but a lot of name brand camshaft manufacturers have a really good quality break-in oil. Additionally, we're going to be adding a Lucas Zinc Plus additive to the break-in oil just for that extra protection. I'll go over the break-in procedure in a little bit more details on the first startup video that we're going to do, but for now all you need to know is we're using a good quality break-in oil to give our flat tappet camshaft and new lifters the best chance to survive the break-in process.
Alright, let's see if this sucker will crank. Guess I should probably hook up the battery first, huh? Alright, take two. Alright, contact. Success! We didn't even dump transmission fluid of the tailstock, so very nice.
So, my rebuilt 350 actually cranks over, and it sounds really healthy. Super stoked. Thank you guys so much for watching the video, and we'll see you in the next one, where hopefully we can get this engine started for the first time.